Welcome students of class 8. Today we'll be discussing chapter number 11, Force and Pressure. So please open your science textbook to page number 105. The first topic that we have under the chapter is the very title of the chapter itself, that is concept of force. So what is a force? Obviously we know a force is either a push or a pull. You can see here at the picture, this girl is opening the door by pulling it. This boy is kicking the football by pushing it. Here pulling and pushing is the act of applying force. This girl is applying force to open the door. This boy is applying force to kick the football. Next we have is at least two objects must interact for a force to come into play. Okay, what it means is that, suppose let's take an example of this football. If there is only one object, only this football, and no other object, no one is acting or applying any force on it, then there will be no displacement in its position, right? It will stay stationary, it will stay at the same place. But if there is a second object that applies a force on it, not necessarily human or a boy or any animal, okay, just wind. Suppose there is a strong wind blowing this side, then this ball will experience a displacement because the wind is applying force over here. So here you look, this football is the first object, then we have another object, that is the wind. So at least two objects must interact for a force to come into play. This is the same one as before. Without interaction, the force cannot be applied to change the state of an object. Of course, if there is no interaction between the wind and the football, suppose if the wind is not very strong, the wind current is not very strong, but instead it is very calm and very mild, then there will be no displacement of the object of the football. After that, we have another topic, that is the effects of force. Okay, force, by applying force we can have different outcomes, different results, right? The first one that we have is force can cause a motion in stationary body, that is body at rest. Stationary means body at rest, that is those objects that are not changing their position. Okay, now we can change the motion of a stationary object by applying force. Like for example, here you look, this chair. At first, if there is no one applying any force on the chair, it will be stationary, it will stay at one position. But as soon as a second object is involved, for example here this girl, she is applying force on this chair. As a result, it is causing the change in position of the chair. The same with this bicycle. Okay, this girl is riding the bicycle, hence she is applying force and the stationary bicycle is now moving. The same with this toy, this boy pulling the toy. Okay, but there is one point that you need to remember, that is, it is not always necessary that a force will make a stationary body move. Okay, like for example here you look, this man is pushing, applying force on this wall, but the wall will not change its position. Why? Because the strength or the force that the man is applying is not strong enough. The same with this pushing of a tree. The force that this boy is applying on this tree is not big enough, hence that is why the tree is not changing its position. The force must be very big. So we can conclude that it is not always, okay, the fact that by applying force a stationary body will move. Next we have this, the second, force can stop. Alright, force can stop a moving body. For example, again this boy you look, he is riding a bicycle. This bicycle is moving, but this boy can stop the motion of this bicycle at any moment by applying brakes, right? And the same with this catching of a ball. This is suppose a cricket ball, right? Now when you throw it, at first it will be in motion, it will move from its initial position and will be in motion, but as soon as someone catches it, that means the motion is broken, hence now the motion is stopped. Force can stop a moving body. First it is going this side, and then as soon as it reach here, it is stopped. The third effect is that force can change the direction of motion of the moving body. If you look here in the case of cricket sport, first the ball will come from this side, it will go, see the motion, the direction is straight this side, but as soon as this batsman applied a force on this ball by batting it, he changed the position of this, he can change the position of this ball to some other directions. First it is going this side, then if so he suppose the other way, bats the other way, see this changing of position. The same is with this girl playing at tennis. At first the ball will come this side, but as soon as she hit it with the racket, it will change its position. Alright. Now the fourth one that we have is force can change the speed of a moving body. Like for example, here you look, this boy is pushing this girl in a moving swing, right? Now he can control the speed of the swing by controlling the force. If he apply much bigger force, the speed will be higher, but if he applied little force, then the motion will be slower. The same is with this boy riding the bicycle. He can control the speed of the bicycle by controlling the force, right? If he wanted to ride very fast, then he will pedal very fast, that means applying force, stronger force. But if he wanted to make the bicycle go a little slower, he can apply brake, that is stopping, little stoppage of the moving of bicycle. Now the fifth one, the last one that we have is force can change the shape and size of a body. By just looking at the picture, you can understand. Here at first, a paper, what is the shape of a paper? The shape of the paper will be a simple plane, right, flat, but by applying force we can change it to different shape. Like for example here, a paper boat. The same with this floor, atta, maida and all those things, okay, you can change the shape. The same it is with this tube here, Colgate, right, you can change the shape by squeezing it. So force can change the shape and size of a body, very obvious. So after all that, now we come to the conceptual parts. That is, the first one that we have is unit of force. What is the unit of force? A unit of force is Newton. Okay, I'll read out first. The SI unit of force is Newton. It is denoted by the letter N. Okay, now if you see any numericals 2, by just writing it 2, the person who is reading it will not directly know what is the context, what is it that we are talking about in the number. Suppose if I put here seconds, then we immediately know that we are talking about time, right? So now if we put here N, then it means that 2 Newton. So you must immediately know that we are talking about force. So here the SI unit is Newton. 100 gram is equal to 1 Newton. So like here you look, you pick up 100 gram on your hand. Okay, the force that it will exert in your hand, that is downward force, right? It will have some weight. That force is equal to 1 Newton. Now next, 1 kilogram force. The force required to lift, okay, to lift means to pick up a body of mass 1 kg vertically upward is called 1 kilogram force. Suppose here this is an object, the weight is 1 kg. Now to pick up this 1 kg object from the floor, you will have to apply 9.8 Newton force, that is approximately 10 Newton. Okay, the force that is required to pick up this 1 kg Newton is 10 Newton or 9.8 Newton to be exact. Now 1 kg force is also equal to 1000 gram force, because we already know 1 kg is equal to 1000 gram, right? And for 100 gram it is 1 newton, so 100 into 10 is 1000, right? So that means this into 10 also, it is 10 newtons. So 1 kg is equal to 10 newtons, the force required to lift. Okay, now another concept that we have is resultant force or net force. Net force means the total force that is acting on the object. Here you look at this picture. These two boys, obviously they will have a different strength, they can apply different force, right? They can control the amount of force they applied on the object, on this card. Now in this example, the boy, yellow shirt boy, is applying 50 newton. The purple shirt or the brinjal shirt boy is applying 40 newton. Now if we add them together, 90 newtons. Now that means that both of these boy total they are applying 90 newton force on this card. That will cause it to change its position. Next we have is when two objects act on an object in opposite direction, the resultant force becomes 0. You look at this picture, this boy is also applying 40 newton from this side, that boy is also applying 40 newton from that side. So obviously it is common sense, right? By applying just simple logic, you will know that this card will not change its position because the forces are acting separately. So if we make it mathematically, then we can derive this 40 minus 40, because this is also applying this side, this is also applying this side, so they will cancel each other out, and hence the outcome, the resultant, the total force is becoming 0. Hence this object will not change its position. Resultant force becomes 0, the outcome force. Such forces are said to be balance force. Okay, this type of forces can also be called balance force. After that, the last one that we have is when two unequal force act on opposite direction on an object, the resultant force is found to be difference between the two forces. That means here you look, this is a tug or war, right, game. Now there are 3 boys this side, 3 boys this side. They may have equal force. If they have equal strength, then they will both cancel each other out, and this rope will not change its position. But in case this side has bigger force and this side has smaller force, then obviously this side will win. Why? Because common sense, obviously, but to show you mathematically, it will be like this. 50 we can we can write like this, right? Not 5 here, 10. 40 plus 10 is of course 50. Here we will write 40. Now 40 and 40 will cancel each other out. The remaining is 10. So that remaining 10 is the resultant force that is making this rope change its position. That is, it will change from, suppose in this point will move this side. It will go this way. It moves the body in the direction of the larger force. Such forces are said to be unbalanced because one side is bigger than the other side. In case of balance, both sides the force is equal, but in case of unbalance, one side will have a bigger force. Alright. Now after all that, we come to this slide where we will solve a mathematical problem. Okay, if you open your book to page number 117 and look at question number G, sub question number 1, you will find it. Alright, now I first read out the question so that we can understand what is it really asking us. In a game of tug of war means like this, okay, like this. That is the pulling of rope. There are 3 girls on team A. Pull the rope with the forces of each of these girls has how many? One girl has 80 newton, another has 100 newton, and the third one has 120 newton in team A. Now in team B, another 3 girls, okay, they have how much? The total, the different forces of each this girl, it is 85 Newton, the first girl. Then the second girl has 105 Newton, and the last girl has 125 Newton. So obviously by just looking at it, you will know that you will have to sum up these two separately. You will have to add it all up. So which side has bigger force? Obviously that side will win, right? So we will try to solve it. Now firstly we will write given force exerted by team A. So what are the force that each of the girls exerted? The first one is 80, then the second one is 100, and the third one is 120 Newton. Now we put here Newton, so we immediately know that we are talking about force. So if you add it all up, how much will you get? 80 plus 120 is 200, 200 plus 100 is 300, so 300. Okay, now the force exerted by team B. I forgot to write here A, and now team B. So what are the numbers in team B? 85 plus 105 plus 125 Newton. If you add it all up, how much will you get? You will get 315. Okay, so now by just looking at it, we already know which side won the tug of war. Obviously team B, but we will have to show it mathematically, right? And also we have to find the resultant force. That means the force that made the rope move. So therefore resultant force is equal to, we will have to subtract team B from team A. So team B minus team A. So what are the values? 315 minus 300. Now the resultant force is 15. Obviously that means here 315 minus 300. 315 we can write as 300 plus 15, right? And here 300. Now this 300 and this 300 will cancel each other out. They will balance each other out. And the remaining force is 15. So it is the remaining force, the resultant force that made the rope move into one certain direction. Now I don't have a space downside, that's why I will write above. Therefore team B is the winner. Alright then, I hope you have understood. So with this I will conclude the video. Thank you very much for watching.